Okay, this may be a little bit better. I put the wrong one up there. So it's my fault. I apologize. We went over this before. Why do we want a TAF? Look, it appears. A little applause. That's good. Glad to see you appreciate that. Does anybody know when you walk out in that field there how you can tell whether it's 3-mile visibility? I don't, because I can't see anything that's 3 miles away. Because everything around you, the trees and the buildings, block your view of 3 miles. 3 miles is a long way. A long way. Okay, visibility, of course, and precipitation will spoil most of the planned drone operation. You certainly probably don't want to be flying it in the weather, but if you have a weatherproof drone and somebody needs to have information photographed or videotaped in that weather, then you need to stand there in the middle of the rain and go ahead and do it. But you can only do it under an umbrella, can't you? You don't need to be out in the open. Okay, so where do we start? Same place as before. We begin by choosing an airport of interest, Fresno Air Terminal. Start with KFAT. And why do we start with a K as opposed to FAT? Andrew, why do we start with a K? International what? Okay, it refers to what now? You could elaborate on that answer a little bit. It's a code that represents the U.S. airports, right? Okay. And other countries around the world have different leading letters in their airport identifiers. I don't remember very many of them. France probably is F, Canada might be C, Germany but G, that sort of thing. But I don't know for sure. Okay, so now we're going to add the date. Now you got to pay attention to this date, guys, because there are going to be a couple of more dates in the forecast. This is simply the date of issuance. The date and the time, we'll show the time in a minute, that it was issued. And it may or may not have anything to do with the forecast period. That is the time beginning to end of when the forecast is valid. It's not going to simply say the forecast is for 12 o'clock noon tomorrow. That's not sufficient. It's going to say the forecast is good from noon tomorrow to noon the next day. There will be some period of which the forecast is valid. All right? Okay, so we add the date. In this particular case, it's today, November 1st. And I got this off of FAT. I got it off this morning, as you'll see in a minute. Now you add the time. Again, the time is only at the moment that they issued the TAF. And that's to give you an idea of how far in advance you think this forecast is good. Because if you're a pilot, whether you're a pilot of a drone or you're a pilot of an aircraft, not only are you going to be happy to get a forecast, but you're also going to want to know when it was issued. And if it was issued at 6 o'clock this morning, but you know that by now some major things have happened in the weather all over the state, that forecast made at 4 o'clock or 6 o'clock in the morning may not be good anymore. So you need to know not only is when the forecast is valid, but also when it was issued. That means that a couple hours before that, some people at the National Weather Service sat and looked at a mass of data coming in from two major models that operate in North America. There's a North American model, NAM, and there's something else. I forget the abbreviation for the second model, but they're gigantic models that require huge supercomputers that are blazingly fast in order to come up with the information. Okay, so the time in this particular case, we go back to Greenwich Mean Time. They call it Zulu. They also call it UTC, Universal Coordinated Time. And why they have it backwards is probably because of the of the French or the German or the European influence on lettering things. They call it Universal Coordinated Time, but it's UTC. Right? So, here's the first part of the TAF. Right? We've got the airport, we've got the first day of the month, today is November, and we've got 11:34. What time is that locally? Eric, what time is that locally? It's what? Now, 8 hours, we are 8 hours different. If it's Pacific Standard Time. But if it's Pacific Daylight Time, it's only 7 hours. So this was issued at what time this morning? Jordy, what time was this issued this morning? What, do you know which part is the time? Isn't the time 1134? And so if you subtract 7 from that, what do you get? 4:34 in the morning, right? Right? Pretty easy. Yeah, it was early. And by the time I get up in the morning and I get my aircraft ready, I'm going to take a look not only at the forecast for the airport up in Oregon, I'm also going to find out what time it was issued. Then I'm going to look at a map and I'm going to look at the movement of weather systems to see if the people who published this at 4:34 in the morning had enough information. And sometimes I've found they don't have enough information. Okay, so now we add the forecast period. There will always be a forecast period. That's the whole nature of a TAF, a TAF, a forecast. So here we're starting with 0112. So the forecast period now is from the 1st of November at 1200 Zulu, right? Because these reports, the METAR and the TAF, are all Zulu time, UCT time, Greenwich Mean Time. So you have Z, or you have UTC, you have GMT, Greenwich Mean Time. You have 3 ways of identifying. I don't know why they couldn't just agree on one specific way, but in fact, this is unfortunately, that's the way it is. All right, so from today, November 1st, at 1200 Greenwich Mean Time, right? And that would be 5 o'clock this morning, right? 5 o'clock this morning? Everybody get that? Okay. So 01 is the first day of the current month, November. 12 is the start of the time of forecast, 1200 Zulu, which is 5 o'clock this morning. So this forecast, so you see, it's interesting, isn't it? Because they issued it at 4:34, and the time of forecast began at 5. So that's pretty good. It's pretty close between the time of issuance and the time when the forecast period begins. It's only 26 minutes, right? So that's good. Okay, so now here's the end of the forecast period. In this case, it's tomorrow, 02, at the same time, right? At 1200 Zulu. So now we know that in this particular case, it establishes a 24-hour forecast period from today at 5 a.m. till tomorrow at 5 a.m. Local time. So now you happen to have a 24-hour forecast period. That's not always the case. I'm going to show you a TAF from O'Hare Airport in Chicago, which is a little bit more complicated than anything that you'll see out here if you're only dealing with small airports, including, even FAT is not a big airport, so it's not going to have a lot of complications on the forecast period. Because what I'm going to tell you ahead of time is, on a forecast period like O'Hare, they don't just do 24 hours. They start doing them in 4-hour segments. So from this time it'll be this, from this time it'll be this. You'll see that in a minute. Okay, 12 is the end of the forecast time of forecast. So now we have when it was issued for Fresno Air Terminal. We have the date and the time that it began and the date and the time it ended. So that's our whole thing right here. So far, we've got that information. But that doesn't do us any good because we don't know what they're going to forecast. So let's continue on. So now we have that summary of the information so far. So what elements are next? Well, the most important for remote flight are winds, visibility, and clouds, as we mentioned. So let's start with winds. Now we're going to add a wind factor in here. And VRB, what is VRB? VRB, what does that stand for? Dale? Okay, there or way back? Let me know when. Okay. So VRB, guys, come on, VRB. Variable. What you need to do is you need to think the way the FAA thinks and think the way the Weather Service thinks. They try to take the letters of the word and try to make something of it. Remember scattered? SCT? Remember broken? BKN? Remember overcast? OVC? Remember few? FEW? So you need to think the way they think when it comes to abbreviations. You need to know abbreviations. And you need to know the order in which the information is presented. I keep saying those two things, and those two things are really important for you to keep in mind. Is that okay, Dale? Okay. So, VRB means that the wind is from no specific direction at 3 knots. VRB, it means the winds are variable around the compass. Today is not the case, but on warm days, you'll often get a lot of thermals moving through airports because of the heat off the tarmac, and it causes the wind to swirl around 360 degrees in big, big circles, and it affects their wind measurement, so they'll always say variable. And what they mean is that the wind direction meter that they're looking at keeps changing all over the compass. O3KT means that the winds are 3 knots, nautical miles per hour. Nautical miles per hour, so it's NM per hour. Okay, visibility is, okay. Pardon? Well, if it's nautical miles per hour, that's what? So miles per hour, you would multiply knots by 1.15. So 15% more nautical miles are statute miles, right? Because you have 6,076 feet in a nautical mile, and you only have 5,280. So if you have 3 nautical miles, that's 18,000, right? That's 18,000 some odd feet divided by 5,280 is more than 3, right? It's 15% than 3. So you want to convert from knots back to miles per hour, multiply times 1.15 times nautical miles. Okay, so we're going to add a little n here for visibility. P6SM. Anybody want to guess what that P means? They use the word, instead of putting the equal sign, or a plus sign, they use the word P for plus. So if you put a plus in front of a 6, what does that mean to you? What does that mean? A plus in front of the 6. It means that they expect the wind to be, they expect the visibility to be greater than 6 statute miles. So plus 6, P6SM, means that it's more than 6 statute miles. How many more than 6? They don't know. They can't predict that well. I think in glider operations we have some software that does that exceedingly well, so we can tell them what they don't know or what they're not willing to go out on a limb to tell us. 6 statute miles, plus 6 is just P6SM. It's expected to exceed 6 statute miles. Now, we also have a ceiling. That means the clouds again, right? So when you talk about clouds, you have to include ceiling because ceilings are created by clouds. So we're going to show what the ceiling may or may not be. But in all of aviation, if the ceiling information isn't there, and you look up and you see clouds up there and they're solid clouds, what do you think is wrong? It says, if it says there are no clouds, the answer is that there are no clouds, and this is something that is very common in our industry, in aviation, and that is no clouds below 1/2000. And you'll hear that on the recorded messages, if you can dial into the recorded messages, and I will give you phone numbers to do that. Recorded messages tell you that they won't establish that there's a ceiling above 12,000. It's not worth it because most small aircraft don't fly that high. So because they don't fly that high, the Weather Service says no clouds below 1/2000. And that's exactly what they say. When it comes to that piece of information in their automated weather, they say no clouds below 1/2000. So, ceiling. And in the weather reports, there's a space for ceiling, and it's right after visibility, because it sort of belongs with visibility. If the ceiling is 200 feet, you can't see, right? Or you can't see in an airplane. You can in a drone, but you can't see in an airplane. But if you don't see anything that talks about a ceiling, whether it's few, scattered, overcast, or broken, or whatever the terminology, if it's not there, you know that there are no clouds below 1/2000 feet. But they do talk about clouds, huh? In this particular case, for purposes of people who are flying much higher, remember, the commercial airlines use these TAFs, and so do corporate jets use the TAF, and some pretty high-powered single-engine airplanes or twin-engine airplanes. I had to use it all the time above 12,000 because I was always above 12,000 when I was flying that twin-engine airplane. So in that particular case, they say, oh, by the way, there are no clouds below 1/2000, but there's a scattered layer at 20,000 feet. And as I say, in this wording, this is my wording, it is expected to exist at 20,000 feet. Because they're looking at clouds that are 20,000 feet, they're looking at them out over the ocean. And they know that weather system is moving, and it's moving at a specific rate, and they expect those clouds at 20,000 feet to be over the Central Valley at about the time of the forecast. So that's how they say it's expected to exist at 20,000 feet. Because they're looking ahead 24 hours, right? They know how fast these weather systems move. You can see that on TV every night when they do the weather on the news channels. Or the weather channels. So, here's the final TAF. Pretty short, huh? The only complication is the forecast period, but once you get that forecast period identified for yourself and memorized, after that it's pretty simple because, who wants to read this one? Jesus. Start at the beginning. Talk out loud so we can all hear how well you're doing. Okay, when is that local time? Okay, 4:34 in the morning, right? But what does that whole cluster refer to? What does all this refer to? Stones? Avocados? What? Winds, yeah, winds. So, the winds are VRB, what is that? Variable. At 0.3 kT, what is that? 3 nautical miles per hour, right. Okay, who wants to be next? Martine, what's the next one? Martine. This one here, what is that? What does that mean? What is it referring to? First of all, what is that little cluster of letters and numbers? What does it refer to?
Back to the wind, because
So this is wind and this is wind also?
no, that's visibility.
Daniel. Yeah, visibility. Come on, guys. I mean, we just had it 3 minutes ago, right? All right, what's the last one? What does that refer to? Clouds. Right. You were going to say that, right, Osvaldo? Clouds, yeah. And so what is SCT? Anybody remember the percentages of scattered? You're not going to be tested on it. That's correct. Eric, 3/8 to 5/8 sky cover. Okay. What is the 200? How many? 20,000 feet. That's correct. God, you guys did it. Amazing.